Welcome! In this video I'm going to show you the new features and changes coming in version 1.1 of my 3D star map add-on. The new features are Earth rotation, where you can enter time, date and location of an observer and it will give you a correct representation of the night sky. And shifted center, where you can shift the center of the scene to a different star system. This way you can, for example, generate an approximation of the night sky as it can be seen from a different star system. If you already purchased the add-on on Gumroad, you should be able to download the new version for free on Gumroad, and a detailed list of changes and the updated documentation PDF is available through the link in the description. Before we cover the new main features in this add-on, I quickly want to get into the UI changes and some of the smaller new features. Now, first, you can immediately see here in our menu, galactic coordinates is no longer a checkbox, it's now a menu, and you can select between galactic and celestial coordinates just to make things a bit more clear. Then advanced options has been moved up here, and if you click it, you can see disable stars and viewport has been moved to advanced options. Before, if you wanted to render a scene with a lot of stars, then the render times were really slow because Blender had to load all the objects in the scene and it took forever, and disabling the collections in the viewport helped with that. Now it's still faster if you disable the collections, but Blender has really improved in speed over the last few versions, and it's now much more feasible to just keep the collections active if you don't have like all the stars generated, and it's no longer as essential to improve your render times. And Blender has also improved in the map generation speed, so generating stars is now also a bit faster than it was when I first published the add-on. There are also now some new options for representation. Now we have now a factor where you can scale the temperature of the stars, meaning the surface temperature that is used as the blackbody emission color of the stars. If we set this, for example, to 0.5 and generate our scene, then instead of the sun having a surface temperature of 5,700 degrees, it now has 2,800 something degrees, and every other star also has half its surface temperature. As you can see here, the stars are a lot more red or orange in this generation. This just gives you more control over your map generation. Now, by default, all the stars have relative sizes, relative luminosities, and the surface temperature that is like given in the CSV file for the star. Now, before you could set the size and luminosity to uniform, and all stars would have uniform size and luminosity. You can still do that, although this direct option has been removed, but is now found here in this menu, where you can set the size, luminosity, and also the surface temperature now to uniform. But I also made it possible now to switch these things around. So you can set, instead of scaling the star with its relative radius, you can now use, for example, relative luminosity or surface temperature, and also apparent magnitude and distance to scale the star. Now, these values are always the ones that are found in a CSV file and are not changed through stellar motion settings or something else. It's just it's only the data used from the CSV file directly. And you can, for example, use this to color code your stars if you, by distance. If we delete all these stars and set this to distance, and then generate a map with a bit more stars, and this might take a while, you can see that they are color coded through their temperature, through their color, by the distance from Earth. So I cut out the waiting time for the map generation, and you can here immediately see that we have our color coding, and here in the center the stars are more red, and then the further away they get, they become orange, and then they are white, or if we would generate more of them or set this to a higher value, then they would be blue. And this way it just gives you more control how you want to generate these maps. And yeah. There's also now an option to change the object shape of the stars. By default, previously it was always an icosphere, and now you can change that to empty sphere, cube, or UV sphere. Now, if you select empty and generate the map, you can see it's a lot faster than with icospheres. And if we delete that and, for example, cube, you can see we have lots of tiny cubes here instead of icospheres. Then if we click advanced options, you can see we also have a new option to the activate distance filter. Then you don't have to enter like a high number than you used to, like something like that. This, if you wanted to get all the stars, you can just click the activate distance filter and it will include all the stars based on distance. Now we get to one of the new main features of this new version, the Earth rotation. Now if we click here on celestial coordinates, you can see a new option appears down here, which is called Earth rotation. If we click that, you can see that we can now enter latitude and longitude and time zone of our observation point, and also a date and a local time. Now 50 and 0 is very close to London, and for our date we enter let's enter today, December the 8th of 2021, and for local time let's just use like 3 hours past midnight. If you wanted to add like 8 p.m. for example, you would have to enter 20 here, because it uses the 24-hour format. And now if we generate our map, we also want to click on night sky mode and set the star size to uniform, just so that all the stars appear to have the same size as from our observation point. And then we generate the map. Of course, we only have stars within 100 light years here, just so it's faster. And then you can see we have the stars here and an empty object in the middle. And these stars are all parented to the empty object, and the empty object is rotated based on the values that we enter here. And right, and then if we wanted to like get relatively accurate representation, we should also enter a horizon, just add a plane and scale it up, and then you get here the night sky. And just disable these names. And now the stars are of course very small, but if we wanted to generate, if we would generate more stars, then we would see them clearer, or if we would set the size to a higher number. And you also see that here compass coordinates have been added, so you can determine which direction is north, south, east and west. And if we click on advanced options, you can disable this compass generation with this option here. Now that you believe me that this is indeed correct, we want to check this through a website where you can view the live night sky. Link is in the description. And for this, we increase the size of the stars by a bit and set this to 0. And then I'll click on, where is it, star constellations. Then we can see the constellations generated and compare this more easily to the actual night sky. So let's generate the map. This might take a while. I'll skip forward, and then we compare it to the website that shows us how the night sky looked today in London at 3 p.m. No, at 3 a.m. sorry. Okay, so it just finished generating the map. You can see here our star constellations, and if we now enter our horizon, then if we look to the north, you can see here that we have Draco here and Ursa Minor, and what is this? I believe it's a Cepheus, right? And in the south we have Canis Major and Hydra and Puppis and so on. And now when you compare this, if we compare this to the website, you can see that here in the north as well we have Draco and Ursa Minor, and in the south we have Canis Major and Hydra and so on, and it's actually correct. And we can see how the night sky would have looked today at 3 a.m. in very close to London. If you clicked on advanced options, you can also click input local sidereal time here. If you do that, you don't have to enter the date and the longitude anymore, just the latitude and the local sidereal time, which is the start time. And you can just enter this directly here, and it will also give you the same results. What we can also do is we can animate the night sky sphere to rotate based on time that passes. Now to do that, we just delete everything here and regenerate it, and then animate it how it would rotate within 24 hours. So basically one rotation of the Earth, but unfortunately it's not as easy as that, because Earth rotation takes a few minutes less than 24 hours, and that's why if we click here on animate rotation and set the time pass to 24 hours, we can also set first frame and last frame here, and then generate our map. And this might again take a while, and then we can see how the night sky sphere rotates within 24 hours. It's because the Earth rotation takes a bit less than 24 hours, that we get a bit more than 360-degree rotation. Alright, it has finished, and now we can see, as when we move out of the camera, our empty object here is keyframed. It starts at minus 45 degrees, and if we press play, you can see the night sky rotates by 360 degrees, and actually it's a bit more than that, because as I mentioned, one Earth rotation takes a bit less than 24 hours, but this is basically the rotation of the night sky in one day. Earth rotation also allows me to add the 8 planets of our solar system to the generated stars. Without a telescope, the planets appear like stars in the night sky, so it of course makes sense that they should also be represented here. Their position on the night sky is however dependent on date and time, so they are only generated when both night sky mode and Earth rotation are activated. An option to select or deselect the planets is also available here under Others. Here you can see planets, and planets disappears if we deselect Earth rotation, for example, or night sky mode, it disappears. It should also be noted that you need to enter the date and time, and you cannot input the local sidereal time. Then planets can also not be generated based on this information. You need all the date, longitude, latitude, and local time information for that. So let's generate the planets here. We just deactivate our distance filter and then deselect all the star spectral types here, just select planets, and then we enter the date and the local time, and let's just enter 24 hours that have passed, and we keep all the other information as their default values, and then we just click generate map. And then you can see here under the collection Other, we have our 8 planets that were generated based on the information here. And if we now press play, you can see the axis moves as the planets would move here around the night sky because of the Earth rotation. But the planets also themselves change their position, so we have to add individual keyframes to each planet, because if we, for example, just delete this empty, you can see here that the planets are, I think you can see this better for Mercury, for example. Here you can see that Mercury is actually moving a bit on the night sky within 24 hours, and if we would set this to a higher number, you would see it more clearly, but I think you can still see the movement here. Now, this is calculated exactly like stellar motion and night sky mode combined, so we have a keyframe every we have a keyframe step size, which is set to 5 here, and each 5 frames generates a keyframe, and you can set this to 1, then the animation is more accurate, or you can set this to a higher number, then the generation is faster. Now the color of the stars is of course not dependent on surface temperature. They are not stars, so they do not emit light themselves, they just reflect the light of the sun. So the reflected light is kind of like dependent on their surface, which, for example, Mars is red and also appears kind of red on the night sky. So that's why I just chose here a color for these planets, and this color is dependent on an average that was calculated from a 360-degree image of the planets. But you can of course always change that how you want. Now the emission strength is dependent on the apparent magnitude. This apparent magnitude is also calculated based on the current distance of these planets to in comparison to Earth, and it also changes of course here with the keyframes. Now the next new feature that I want to show you is just a helpful tool and actually won't generate anything in Blender. If we select advanced options and go all the way down, you can see there's another operator here called print data to console. And what this does is it basically, instead of generating a map, it prints the information that is in the CSV file dependent on the filters here to Blender's console. Now, for example, if you wanted to find out specific information about a specific star, then you just type in here under the name filter, for example, Sirius, and then you press print data to console. And then if you go to the console under window, toggle system console, then you can see here we have generated information about Sirius that is directly gathered from the CSV file. So here in this case, we have, for example, the non-proper name that is shown, the galactic coordinates, celestial coordinates, the distance, spectral class, and so on. And some of these values are only available for a few stars, so if they're not available, they won't show up here. Now, if you have multiple stars, for example, if we remove Sirius here and then just type in 10, which will generate which will print the data of all the stars within 10 light years to the sun or to Earth, to our console, then we can see here we have the stars starting with the sun. We have the information about the stars within 10 light years, and it's always sorted by distance, just because the CSV file is organized, is sorted by distance, and it reads the CSV file from top to bottom to find these stars. So this allows you to just have a bit clearer understanding of the information that is used to generate the maps, and it's also handy for the next feature that I want to show you. This new feature is called Shifted Center, and it allows you to select a new center point for the generated map. By default, this is of course the sun, but now you can change that to a preset or to custom coordinates. This option is available if you click Advanced option and go all the way down here, and then select here Shifted Center. And here you can enter custom coordinates, and you can immediately see how the print data to console operator comes in handy. You could directly copy this information from the console to here if you want the center point at a specific star system. Just make sure that if you select galactic coordinates here, you copy in the galactic coordinates. If you select celestial coordinates, you copy in the celestial coordinates here. This feature also works with stellar motion. So if we click this, you can see here, you can enter the proper motion parameters for the new center point or the new star system that you selected. So let's do that, for example, for Barnard's star. Just enter this here, print this data to console, and then we can check here our values for Barnard's star, and just copy the galactic coordinates because we selected galactic over here. Copy these in, and then our velocity is given in light years per 1000 years. That's because just for most stars the velocity is quite small, and otherwise you would just have to copy very small numbers in here. Okay, so now let's generate the map, and you can see, oh, I forgot I should have to remove the name filter here. Now let's generate the map, and then you can see we have all the stars within 100 light years of Barnard's star. That's because we selected here use shifted distance for distance filter. Otherwise, if we select this, it would use all the stars within 100 light years of the sun. And now we have Barnard's star here at our center, and the sun is over here. And as you can see, if we press play, all the stars are moving, and Barnard's star is in the middle and is not moving, and the movement is all relative towards Barnard's star instead of the sun, as it would be by default. Instead of entering all these coordinates, you can also choose one of these preset stars. These are mostly bright stars, but also some are important stars positions like the North Star Polaris or the center of the galaxy that I selected. And then you can just for example, select Canopus, which is the star system of the planet Arrakis in the Dune books and movie. And then you just generate the map here, and you get Canopus in the center and all the stars within 100 light years around it. And then you press play, and then you can see these stars are moving, and you don't have to enter any coordinates. I quickly want to show you how you can do your own presets. For this, you have to change the script of the add-on. You'll find this on Windows on the path that I'll show on the screen now. And here you open the script, go to line 3662, and here is the code for this specific option, and you can see all the presets here. And for this, you just make a new line, and then you can enter here the name of the star as it is in the CSV data file. That's the default name that shows up if you generate a map, so with these brackets of the multiple star system, and then here is the name of that is shown in the preset options. And then that's basically it. For this I use Notepad++, but you can use also just a basic Windows text editor or something similar to change the script. Then you save it and you should be good to go and have a new preset. The way this works is that it searches for the name that you enter on the first position in the script, and then it searches the CSV file for this star, and then it gathers the information it needs from the file and then uses it to shift the center based on that. So it's very easy to just do your own presets. You don't have to do complicated scripting for that. Now, the shifted center feature also works with night sky mode. For example, if you want to see how the night sky could look from for example, Arrakis, which is the planet, as I mentioned, of the Dune movie or books, that is in the star system Canopus, then you would delete all these stars here and click night sky mode, select stellar motion, and then you would set this to a very high number, or deactivate distance filters. You would get all the stars, and then you generate the map, and then you have the night sky of Arrakis, for example, or any other star system that you want. Now, there are of course some limitations to that, mainly because there are only 3,750 stars approximately in this add-on, and most of these stars are of course closer to the sun, so the further you go away, the lesser stars will be around that star system, which means that if you look in the direction of the sun from Arrakis, for example, you would get quite a lot of stars and a quite realistic night sky, so to say, but if you would look into the other direction, it would be quite empty, unfortunately. Now, of course, you also don't know the position of an observer on another planet in the selected star system, so you wouldn't know how to rotate the night sky. Another issue is the emission strength of the stars. By default, night sky mode uses the apparent magnitude of the stars to calculate its emission strength. Of course, this cannot be used for different center points and has to be recalculated based on a new distance between the star and the new center point. If you calculate the luminosity from a star's apparent magnitude, you sometimes get inaccurate results because light can be obstructed on its way to Earth. Therefore, it is impossible to calculate accurate emission strengths of stars as seen from a random star system based on the data here. However, the add-on does use an approximation of the emission strengths, and I added an option that lets you choose how it is calculated. You can calculate it based on apparent magnitude, which is then turned into absolute magnitude, and then uses the new distance to calculate the absolute magnitude at a new star system. Or you can select the inherent luminosity that is then used to calculate the apparent magnitude at a different center point. For some stars, the difference is barely noticeable. Others can have quite different emission strengths depending on your selection here. Now I covered all the new features in version 1.1. Now is a good opportunity to quickly talk about my future plans for this add-on. With this version, I added a lot of new functionality, but I did not add any new stars to the CSV data file. At some point, I want to do that and increase the number of stars included, and I also want to go through all the data again at some point and check if it is still up to date and update it accordingly. I also want to thank everyone who has bought the add-on, and I hope everyone is enjoying it. I want to apologize that it sometimes takes me quite a while to answer questions on Reddit or YouTube, but in the end I always do answer, so feel free to ask questions. So thank you for your time and enjoy the new features.